The secret of Earth's climate change is in this place. Researchers from The Ohio State University used dust trapped in glacial ice in Tibet to document past changes in Earth's complex climate system. They also believe that maybe one day this will help predict future changes. Their findings show that the composition of the dust and samples collected from different areas and depths of the same glacier can vary widely. A discovery that hints that a complete dust record may reveal more secrets than scientists realized. Dust stirred up by strong winds can cause a series of chain reactions in the atmosphere. This affects everything from human health and ocean biochemistry to the balance of carbon dioxide in the atmosphere. How these microparticles affect the surrounding atmosphere depends largely on their size, shape, and chemical makeup. In a new study published in the journal Geosciences titled Aeolian Dust Preserved in the Gulia Ice Cap, Northwestern Tibet, a promising paleo-environmental messenger, researchers are working to help understand how dust affects climate. By examining dust particles locked within ancient ice, or what Emily Bowden, a co-author of the study and senior research fellow at the Byrd Polar and Climate Research Center, calls cryodust. By looking at the composition of the dust through the ice, we can extract information about the state of the Earth's environment at the time snow was deposited and ice was formed, he said. We might be able to study whether it was a relatively dry or wet period or try to infer where the dust came from, and thus gain information about past atmospheric influences. But researchers need a lot of ice to be able to collect that data. Ice cores, ice cylinders drilled from glaciers and ice caps, have long been used as comprehensive archives of Earth's climate system because they are so well preserved. As permafrost builds up over seasons and years, aerosols accumulate within each new layer, ultimately providing researchers with an incredibly detailed record of the planet's tumultuous climatic history. With the help of this natural time capsule, scientists can study what the world was like at that time, including aspects such as greenhouse gas concentrations, as well as volcanic, solar, and biological activity. The ice used in this study was collected from the Gulia ice caps in northwest Tibet. It is an area home to one of the largest sources of atmospheric dust in the northern hemisphere, second only to the Sahara Desert. Because the region is under the influence of westerly winds, a lot of the dust they carry is blown into major cities in East Asia, Bowden said. For example, in 2021, China experienced its biggest dust storm in a decade as it forced entire cities to take shelter, which ultimately raises concern from the scientific community about the impact of climate change on the frequency and intensity of such events. But scientists don't have enough data to help identify how Central Asian desert dust is transported over long distances, or how it changes over time. Studying the dust record from the Tibetan ice core is the only way to provide a long-term perspective on the Central Asian dust cycle, said Bowden. In 2015, a team of researchers from the United States and China helped drill ice cores from various locations in the Gulia ice cap before sending these ice cores back to a lab at Ohio State. Bowden's team analyzed 2 ice cores, investigating the dust record in the area by studying microparticles collected on filters from melted ice, as well as particles trapped in subsamples of ordinary ice. Bowden noticed that the encapsulated dust was not uniform. Instead, each deposit is an impossible array of different colors, sizes, and layers. What we wanted to prove with these initial samples was there was actual variability in their geochemistry and mineralogy, he said. We found that not all of the same dust comes from the same desert, and even in the same glaciers, you don't always have the same ingredients. Overall, the study notes that the very old Gulia glacial dust archive is a prime candidate for deeper exploration. Opened up many avenues of research, including studying the microbial populations present in the ice and consuming the cryodust nutrients carried within it. Ultimately, Bowden envisions his work helping investigate glacial records of extraterrestrial planets. My goal is to gain a lot of expertise in cryodust, he says. If there are ice cores being drilled or samples taken from Mars or other planets, I hope to be able to study them. That was research on the Earth's climate. Thank you for watching this video. Please like and subscribe to develop this channel together.